Okay, we're live right now. Okay. Okay. Okay, so today we're going to look at dot product, the detail of it. Last time I just started off the vectors and so on. So we're going to look at what is dot product. Oh, you can't see anything, sorry. No one even said anything too. How y'all doing? Did you guys start doing the assignments? Okay. Huh? Should I darken it? Gia, can you press one of the switch? Ren and Gia, you don't need the name tag. No, not you guys. Go all the way to the end. Third one to the end. Third one. Yeah. There you go. Thank you. Can you guys see it? Yeah? It's not bright enough? Oh, the red is a bad color in this class. That's right. You are disgusting. Don't you call my awesome highlighter color disgusting? You're rude. What? You guys had me before and you're figuring that out? I'm rude right now? I'm best friend with Donald Trump, so. Alrighty then. Dot product. In the 2-dimension, we're going to look at it, and in the 3rd dimension, or any dimension. Can you guys see it? Oh, I gotta learn how to turn this off. Multiply a vector with a vector to get a scalar. It is also called the scalar product. Okay. Let's look at an example. Ooh, I should add some other interesting color to it. The red is no bueno, right? Add that. Do I have? Tell me if this is good. Is this good? No? No? Okay. Oh, I have that much color. That's it. I should have more colors. I don't have them. What about this one? No? Let's try this one, see what happens. Okay. All right, good. So let's look at an example of it. -4, 5, 6. Pretty simple. 1 times -4 plus 2 times 5 plus -3 times 6. And what is it? All right, let's go. Back there. What is it? Is that correct? Yes or no? William? You ran out of M. By the time I went to M, you became William. All right, rules for dot product. Rules for dot products. Most obvious. Most obvious rules are true. Do you guys know what this is called? Huh? Do you know what is this called? Commutative property. A times B equals B times A. Did they teach you guys this in early, like high school math? Like 6th grade, 7th grade, right? Associative property, commutative property. Yeah? Okay. A plus B times C equals A times C plus B times C. All right, now comes the important part. Angles between the vectors. You're going to see that a lot. We're going to look at angle between the vectors. Okay, we still haven't gone remote yet. Couple classes went remote. I don't know why they went remote. Do you know any classes went remote after they became in person? Anybody knows? Okay. Like if one of you died, then we will become remote for sure. If I die, you all fail. I wrote it to our who are those secretary? Yeah, I wrote it like if I die from COVID-19, everybody fails. So it's in there. So you don't get automatic. Yeah. Ask Leo how. Like if you think I'm lying, I don't lie about those things, right, Leo? Yes. Angles between two vectors. So if you try to draw it, this is what's going on. Here's one vector, here's another vector. We're trying to find this angle. What is this angle, right? So this vectors could be in the 2 dimension, could be in the 3rd dimension, or any other dimension. All right, so let's look at it. So we're going to assume non-zero vector. All right, let's use this. U is U1, U2, U3, and V is V1, V2, V3. Here's your angle. Does YouTube automatically add subtitles? Because I have to be ADA compliant. If you cannot like not see here, then you have to be able to read it. So I don't have anybody like. Let me know if you have hearing disability. So I have to go turn on the subtitle. All right, what does this look like? Once I write it down, what does this formula kind of look like? Do you remember your Math 127? No, no, kind of not law of cosine. When you have to deal with force tensions, the angles, it's kind of like that. Do you guys remember that? No? No? Okay. Did you guys take my Math 127? Leonard, you didn't take it? Okay. Another way of writing, what does this top part looks like? It's a dot product. What? Oh, because you see the stuff on the bottom? No, not quite, yeah. Do you guys see it? Now? You're going to see this over and over and over again. Okay? Good. Hey, isn't that like a Nevada Health? They're providing like 60,000 like testing for free. Like, how is that Costco? And all of a sudden I got a report on my phone. It's like, emergency, you got free COVID-19 test. Yeah? Right? Did you guys get that? Oh my God. It's just scary. The people who has to do the COVID-19 test, how many of them would end up catching them?
I don't think you have a single one.
Single one what?
I don't think you have a single person that does the testing.
I don't think you guys were doing it massively. Now I think because they got some funding from this federal, now they're going to do massive, yeah.
Temporary installation.
But here's the thing is, if you're smart and you follow the rule, you shouldn't be affected. If you're stupid and you think you're too good for it, then you will get affected and you will die from it. So in a way, that's a good selection process, right? Nature is selecting out those idiots, right? They used to have that in olden days, when children were little. It's called playground. They didn't have sand. They didn't have anything. They had rusted like sliding and all that. And you have to recognize it that nope, I'm not gonna slide on it. And the kids who did it died from that, right? Okay, you kids don't know what I'm talking about, but in those days they had the monkey bar. It was so high. You fall from it, you break your leg. But that's the truth. What is it? I was reading this Reddit because of a bunch of hurricanes happened in Louisiana, Texas, and like 2 years in a row. And only this type of lizard survived, basically sticking to the branches and couldn't fly off. It was one of the genetic mutations they got it, and those were the only lizards that survived because of the high winds. So there you go. That's your another natural selection. You guys don't have Reddit? You don't spend. Yeah, but it was the weird mutations that they had it, and they were the only ones survived. All the other lizards died because of the wind killed them off in that region. All right, find the angle, guys. Can you guys do the dot product of it? What's the dot product, Julio? All right, Gia, Miss Yamat. Is that your last name? I know your last name, right? But how do you say it? I said it right? What's the ethnicity? What is it? It's huh? Filipino. That's more. Is it like Filipino or Spanish? Oh, what? That's what I'm thinking right now. But like, even they named the country over the Spanish king, so everything is about the Catholic and Spanish colonialism in those Philippines. So I don't know about nowadays. All right, what is it, guys? What's the dot product, Julio? No, dot product. I just gave it to you earlier. Yeah, dot product, guys. What is it? Is it back there? I can't see your name tag, buddy, or I can't read it. Yeah, the black mask. Okay, make it your name tag, and the other one too. I can't read it. Darken it. Huh? Yeah, but write it down. I'm not gonna remember. Like I had them before. That's how I know them. I didn't have you guys. I had them for like what is it? 2 semesters?
You got me for top one and top two.
Yeah. Yeah, yeah. So that's how I know them. So I'm not gonna remember you guys. What is it? -4, right? What's the magnitude of U and magnitude of V? What are they? That is correct. So what's the angle? Angle tells us what? Cosine inverse of -4 times 21. Give me the answer in terms of degree. Round it to the nearest 100th place, second place. Princess. That's like such a cool name. Like, I mean, if you have like, but Prince, he came up with his own name. The singer Prince, right? That wasn't his birth name, right? The Prince who died, right? Do you guys know? From 80s singer? Yeah, that's the singer. What? Prince. His name is Prince, right?
I don't know if that was his real name or if he
No, he came up with his name, yeah. All right, what's the angle? Yes, Kenna. Wait, what are you saying? It's not U times V, it's a dot product. I just gave you the dot product earlier. Right over here. So what's the angle? All right, Walter. Oh, you guys haven't plugged that thing yet? Make sure it's in degree. I'm waiting for Walter. He was born with the name Prince?
His full name was Prince Rogers Nelson, and he went through a lot of name changes until he settled on Prince for his stage name because his birth.
Oh. All right, Walter. What is it? You're using the new calculator, right? It's taking time. That's okay. We'll wait. We'll wait. Okay, let me get somebody else. Chris. I said round it to the nearest 100th place or second decimal place.
0.98. Yeah, 100.98.
Okay. All right, good guys. All right, now we're gonna look at orthogonal vectors. So orthogonal. Any English major over here? What is orthogonal? What does it mean? Ortho, does it mean anything to you guys? I'm curious. Any? Nothing? It has to do with when two vectors are 90 degrees to each other. Well, yeah, that's what I'm trying to figure out. Basically, what it means, it's not really 90 degree. It happens to be 90 degree because when vectors u and v are orthogonal, if the dot product, there's 0. (90°). Yeah, good. Now the vector projections of u and v is the vector. So we're going to look at the projection of vector u over v. So that's what we'll be looking at. Ready? Vector projection of u and v is the vector. Here's the projection. You get the dot product. At the bottom, instead of doing the UV, so remember how we have to do the angle of it? Now this one is times V. So if I'm using that this symbol over here in this class right now, it means dot. If I don't use the symbol, it means multiplication. Dot. This means good. Oh, I could pick hot pink. Oh my god, I could have picked hot pink. All right, let's find hot pink. Where's the hot pink? Oh, there you go. This one might be, yes. All right, let's see. How's the color showing up? Yes.
The projection, just on the left side of the equation, is that u and parentheses?
Are you talking about this? Can you guys see this? Hold on. Are you talking about this?
Oh no, just read that.
Oh, it's projection of u over v.
Of u over v.
Yeah. Projection of u and v. That means it's like you're looking projection of u over v. Kind of like that. Don't say it out like that. But. Can you guys see this color? Pink? Oh yeah? Okay. The scalar component of u in, because you're understanding what's happening. It gives you direction what's going on. You're looking at the projection u over v.
So you're using that to be on the outside of the unit vector.
Kind of like that, yeah. You're looking at two vector. You're looking at the projections of u. We're gonna go a little bit drawing of it, and you'll see later on what the heck does that mean. Yeah. Direction of v is the scalar cosine of theta. What am I doing over here, guys? Can you guys see the pointer? Can you guys see it? Hard. Okay. All right. And then magnitude of v, which is, yeah, you could do this way too. So let's look at an example problem. Find the vector projection of u 6i plus 3j plus k onto v I minus 2j minus 2k and the scalar component of u in the direction of v. Okay. Actually, you know what? Like after the last class, I've decided when I finish my lecture, because of the COVID-19, I'm not gonna have you guys stay unless like we have to do something special, okay? Because it's like we kind of increase the risk factor of it. So, do you guys live with anybody or elderly people? Okay, that's you guys are, and like you guys, what? No, I'm talking about like 65 and above. Yeah, I mean that's when they're risk factor. Did you guys read one of the article? One of the big, they're saying that the people who got affected by COVID-19, like massively, not all, but huge populations their eating habit is not healthy. Like they have other conditions with it. So if you eat like junk food, like not healthy thing, oh my God, you guys are dead. Again, that's another natural selection. So. All right, let's look at it. I'll get once in a while, I'll get people saying that evolution is a theory. I'm like, yes. Do you know the definition of theory? It's something that's been proven, and until someone comes in and improves it better. It's not they're gonna say, oh, it's completely wrong. Like Earth is round, all of a sudden Earth is flat. Leo and Gia and Rin knows my pain. I stopped going to the hair guy. I stopped seeing him.
He said you up? Don't wear a black?
No, I can't deal with him anymore. It's like,
I thought you were gonna convince him.
no, it's like I tried, and then next thing he says that Trump is selected by God to fight the Satan in our society. I'm like, who are the Satan? Like, look at all the pop stars. The only way they become top idols is because they sold their soul to the devil to become that. So yeah. So what is that? What's happening over here? U dot V square times V. Right, guys? So can you guys figure this out? What is this? I'll give you a little bit more time. And what is my V in this case? V is I minus 2j minus 2k. And we're going to multiply it. Is it done? Yeah, Justin? Negative 2/3? Really? Negative 2/3? What? Negative 2/9? Okay, let's do it. What's u, maybe I wrote it incorrectly. What's u dot v? Is it negative 2? I had the answer wrong then. So let's look at it. 6 minus 6 No, it's 4. Oh, did I give you the wrong question? Okay. This is supposed to be 2. Yes, I can. You cannot change it. That's the 11th commandment. We'll get there. Like, we'll get there. What if Moses really came up with that? He was going, I was like, all right, that makes more sense. It's like, this commandment makes sense. Like, what is it? I was reading this, and it's one of the things it says that you cannot do it with goat in the Bible. Apparently, it was a big problem for that people. They had to write it down that no, you cannot do it with goats. Yes. Yeah, I gotta find that out. It's in the Old Testament. So there were some tribes like they were going hanky panky with the goats. So
You're not recording this session, right?
oh damn it! Next thing I get a phone call from Fox News, Tucker Carlson. What are you teaching to the kids? That's what we have, right? And when you multiply the vectors, you get. Oh, I don't need to do the bracket. Next, we're going to find the scalar component of u in the direction of v. And we're going to look at the application. What is this projection? What's happening? Okay? Scalar component of u in the direction of v. U cosine of theta we'll just do the okay, yeah, I'll do this vector. Okay. Yeah, we'll do that. Again, dot product. What do you guys get? Yeah. No. Like, you could do the dot product, divide by the magnitude, but what I've done is I've done this part first. So I'm multiplying a dot product with a unit vector. Oh, I need some coffee. You guys got that? What's the answer? Rin. What? Yeah, what's it? So what is it? Back there, Alex. What is it? What? You got only 4/3? Okay, negative 4/3. That is correct.
What if we all lie? And that's actually the answer.
I have the answer right here.
You know it's wrong.
What?
You know the answer's over there could be wrong.
No, no.
Yeah, you just have one.
No, I just wrote it down the question incorrectly. That's why I had to look back to look at the input of it to make sure it was correct. And also, I'm like infallible. Like, I'm better than Pope. Pope can make mistake, but not me. Any Catholics here? Oh my God, I'm still thinking. I'm comparing myself to Pope right now. Yeah, I give up. All right, so let's look at this projection. What the heck? What does it mean? Application. All right. The work done by a constant force F acting through a displacement. Is force D. Again, this is a dot product right over here. So let's look at the object right over here. P Q. Well, when you're kind of pushing it, does it go vertically? I mean, horizontally right away? No, it has some displacement. That's your force right over here. And that's that angle. So there's some stuff going on. So let's look at it. What's happening over here? The work done by a constant force F during a displacement D is earlier I said that which is the dot product. What? Oh, cosine, sorry. Cosine of theta D. Yeah, because if it's just cosine of what? Of magnitude of D, that means nothing. Good job. You can solve crimes right now. What if you do catch a like famous killer? Like Zodiac killer. You know, like Zodiac, nobody knows who's the Zodiac killer. What? Like in California. They don't know who that person is. What? It happened in the 50s, 60s, 70s. Yeah. Rin could solve that, yes. Huh? Why is he called Zodiac? Oh yeah, he would send letters, yeah, with like a hint of like what I've done. He will have detail of it, like yeah. So it was crazy. Yeah, like they had a lot of killers in 60s. Ted, what is that? Ted Bundy? That guy? What?
So it's like the zodiac signs, all the victims had different zodiac signs.
Oh, okay.
But then, like, there was like an Aquarius he killed at one point, but then instead of killing like another one that's like different, he killed another Aquarius.
Then he had, if he knew their sign, that means he
That's just some random.
it ran. Oh, that makes sense. Yeah, yeah.
When they tell us that he owned it, and he's like, yeah, I'm the zodiac.
Oh, okay. I don't know that detail about it. All I saw like 10 minutes of the movie. What is it? 2 days ago, and I passed out. Like in Netflix, there's the movie. Is that within 10 minutes I passed out. Just after the brutal killing, as like all this letter coming, I was like, I want to see more murder, and nothing happened, so I passed out.
You're probably like the Zodiac kid or something.
One of my other class, a student, a couple years ago, he was a psychology major, and no, he diagnosed me that I might be a sociopath. Like, what? hey, I have feelings. And is the Newtons? Displacement is the how far it went, and the angle is 60 degree. The work done by F is acting from P to Q I gave you everything. What's the answer, guys? Joules. What is it? 60J or joules.
You know what else they use about cars about that?
What?
Moment onto some kind of member, like, like a structural member.
Oh, yeah.
Find the torque and like you project how much of that is on that member.
That's all engineering, yeah. I have a lot of MEs. That's what you guys will be working on. All right, now we're going to look at cross product. Wait.